Welcome to Cohive. In this video, we're going to be learning Numpy library for Python, and we are going to use chatgpt to learn about it. It's going to teach us, essentially. You will be explaining Numpy library to an absolute beginner. Give me a list outline of what you will be teaching me from simple to advanced. So give me a list. Let's start with number one. Tell me more. Let's say, tell me more about number one with code examples. Here we go. I'll just pause while it's completing. Okay, so it says Numpy is a Python library that is widely used in data science and scientific computing. It is designed to provide fast and efficient operations on multidimensional arrays, which are essential for many types of data analysis tasks. For example, let's say you have a large data set of temperatures measured at various locations over a period of time. You might want to calculate the average temperature for each location, or the minimum and maximum temperatures for each location. Numpy makes it easy to perform these calculations by providing a set of functions that can operate on entire arrays at once, rather than having to loop through the data manually. Here's an example of how you might use Numpy to calculate the mean temperature for each location. Okay, here it is. So it's given us a Numpy array of 3 different locations. And calculate the mean temperature for each location. Does it like this. And the output should be like that. In this example, let's actually copy it to Visual Studio. I have Numpy installed. You can pip install it by saying pip install Numpy. I already have it installed, so if you don't have it, you have to do that and then import it. And if you run this, it should give us the mean temperatures for each location. There we go, 71, 77.6, and 85. And the axis 1 means the column, from what I understand. And axis 0 is the row, I believe. Let's ask GPT. What is the axis? In Numpy, the term axis refers to a specific dimension of an array. For example, consider the following two-dimensional array. Okay, these are the columns and the rows. Sorry, the rows and then the columns going vertically. This array has two axes. The rows, which are the first axis, is 0. Yep, the rows. And the second axis are the columns. Okay. Yeah. So sums, so if you wanted to say, if you want to calculate the sum of all elements along the rows, we could do this, right? np.sum array on x is 0. Okay. And then 12. Because 1, 4, and 7. Yeah, 1, 4, and 7. And then 2, 5, and 8. Well, wouldn't that be the column? Okay, I guess it works like that. Let's just copy it. And when we run it, we do get 12, 15, and 18. There we go. So it adds 1, 4, and 7, which is 12, 2, 5, and 8, 15. Yeah, just like that. Okay. Numpy, so we already got an example, so we got that answered. Let's move on to number 2. Tell me more about number 2 with code examples. To use Numpy in a Python script, you will first need to install it. This can be done, yeah, pip install Numpy. Alternatively, you can install Numpy using the Anaconda distribution, which comes with a pre-installed set of data science libraries, including Numpy. Once installed, import Numpy as np, which we have done. And then after importing, it's creating an array. So array assignment to np.array. If you print the array, it's like a list. You can also create a NumPy array from a file by using the np.loadText function. Create a NumPy array from a file. We had that file, then it actually creates it. That's pretty cool. There are many other ways to create and manipulate NumPy arrays, which we'll cover more in detail. Tell me more about number 3 with code examples. NumPy arrays are multidimensional collections of data. They can be used to store and manipulate large amounts of data efficiently. They are similar to Python lists, but are more powerful and efficient for certain types of operations. To create a NumPy array, you can use the np.array function and pass it a Python list or tuple of values. Yep, exactly. We've seen that. Create a two-dimensional array, so you're passing two lists, two arrays separated by a comma, and if you print it, you get a two-dimensional array, 2 rows and 3 columns. Create a three-dimensional array. Yeah, pay attention to the square brackets. So these elements are housed within a larger square bracket, and in this case, there's a main bracket, and in it are the 2 elements, and then inside of that is also two separate arrays. So when you print this, you get a structure, an object like this. You can also create arrays with this that's three-dimensional. You can also create why would you need three-dimensional arrays? For example, if you're representing a color photo, each pixel value, RGB value, will have to be represented for each pixel in 3 dimensions, for example. Right? Because the first 2 dimensions are the positions of the pixels, and then the depth is the RGB values. You can also create arrays with a specific shape and data type using the np.zeros, np.ones, and np.empty functions. So for example, you can, if you wanted to initialize an array to a certain, in this case, zeros, you can do that. It's giving you the shape of 3 rows and 4 columns. Yep, and it prints like this. You can also do the same thing with ones. Here it is specifying the type, that it's going to be an integer. You can also specify it to be a float or any other data type for that matter. But with NumPy is that you can use any type of data type, but a particular array has to have all the same data type within a single array. Create an empty array and 2 rows. Why does this? Let's print it. Why is it printing 1 then if it's empty? Oh, we have to import it. Yeah, run it. Yeah, it's just, it should be printing 0, so it's an empty array. So bear in mind that sometimes ChatGPT can make mistakes. You can also create arrays with a specific range of values using the np.arrange function. Create an array with a range of values. For example, here it says np.arrange 10. It's upper bound exclusive arrange, so it's going to be creating from 0 to 10. It's 0 being the first element, up to 9. np.arrange from 5 to 10 is going to result with the first number, and then up to 9, upper bound exclusive. Upper bound exclusive means that this number will not be used within the array. Inclusive, if it was inclusive, then 10 would show up as well. You can also add a step number. For example, np.arrange from starting from 0 to 10, but skipping 2 each time. So that 0, 2, 4, 6, and 8. Let's copy this. And if we run it, we get the exact same result. There are many other ways to create and manipulate NumPy arrays, which we'll cover in more detail. Let me just go back. So we did creating and manipulating NumPy arrays, performing mathematical operations on NumPy arrays. Okay, Tell me more about number 4. Let's just paste it as well, just in case, because it's token size. We're probably getting close to it. It has a memory size of 3,000 or 4,000 tokens, I think. After that, the earlier stuff gets forgotten. With code examples. Numpy provides a large set of functions and methods for performing mathematical operations on arrays. These functions allow you to perform operations on entire arrays at once, rather than having to loop through the data manually. For example, you can use the np.add function to add two arrays element-wise. So if you have two arrays, A and B, 1, 2, 3, 4, 5, 6, you can add them together, and it will add element-wise. 1 plus 4, 5. 2 plus 5 is 7. 3 plus 6 is 9. Let's confirm this real quick. And it is true. You can also use the plus operator to add two arrays. Okay, that's convenient. Let's see that in action. There we go. Other mathematical operations that can be performed on arrays include subtraction, np.subtract, or the minus sign, multiplication, np.multiply, or the multiplication sign, and the same for division, and exponentiation, np.power, or two multiplication signs, one after another. And here it's giving an example to each. Okay, we'll actually skip this as we understand it. You can also use NumPy's universal functions, ufuncs, to perform element-wise operations on arrays. These functions operate on each element of an array and return an array of the same shape. So these functions operate on each element of an array and return an array of the same shape. Okay. We have an array, 1, 2, 3, which is assigned to A. Calculate the square root of each element. np.sqrt does that. And this is the result. Calculate the sign of each element. Okay. Calculate the logarithm of each element. Okay, these are pretty cool if you're, for example, doing computer graphics or computing animations and stuff, or analyzing audio-related, for example, data. These probably come in handy. Let's just take a quick look. Yep. It is absolutely, this obviously the sign is not correct because ChatGPT won't be able to calculate it. But these are the real results. Actually, I'm surprised that it knew the logarithm. Look. So this is its guess, right? It's a language model after all. Oh no, actually that was correct too. Wow, I was just looking at the wrong spot. That's pretty impressive. All right, we can, so there are many, so we can ask, like, why would I need sine and log operations? What would I use them for? Yeah, let's find out. The sine and logarithm functions are just two examples of many mathematical functions that can be applied to NumPy arrays. These functions can be useful in a variety of data analysis tasks depending on the type of data you are working with. For example, the sine function is often used in signal processing to analyze periodic signals. It can be used to extract information about the frequency and amplitude of a signal, or to remove noise from a signal. The logarithm function is often used in machine learning and statistical analysis to transform data. For example, if a data set has a skewed distribution, for example, some values are much larger than others, taking the logarithm of the data can help to normalize the distribution and make it more symmetrical. This can make it easier to apply certain machine learning algorithms or statistical tests to the data. There are many other mathematical functions that can be useful in data analysis, such as the trigonometric functions, cosine, tangent, etc., the exponential functions, np.exp, and the absolute value function, np.abs. It is important to choose the appropriate function based on the type of data you're working with, analysis you want to perform. Cool. Let's go back. Let's say, are there any other important math functions I should know? let's say, because we were looking at that. Here are a few other important mathematical functions that you may find useful in data analysis tests. np.mean calculates the average of an array. np.median calculates the median of an array. So if you're doing statistics, these would come in real handy. np.std calculates the standard deviation of an array. np.coef calculates the correlation coefficient between two arrays. np.col calculates the covariance between two arrays. np. calculates the dot product of two arrays. np.linealc calculates the inverse matrix, and this one solves a linear system of equations. These functions can be useful for a variety of analysis tasks, such as exploring the statistical properties of a dataset, performing regression analysis, or solving linear systems of equations. There are many other mathematical functions available in Numpy, which we will cover in more detail later. Now, we can try to get examples to these. I mean, these are pretty complicated. Mean, median, and standard deviation are probably what most people will use most of the time. Give code examples to these. Let's just try these 3. I mean, we could be getting examples for all of them, but let's get this. Here are some examples. All right. We have an array. We're looking at the mean. Mean is the average. 1 plus 2 plus 3 plus 4, 5. That is 10, 15 divided by 1, 2, 3, 4, 5, which is 3. Adding all the numbers, dividing by the number of elements, right? That's the average. That's what the mean means. Calculate the median of the array. Median, I believe, is the middle element, which in this case is also 3. Calculate the standard deviation. Turns out to be 1.58. You can also specify the axis parameter to calculate the mean, median, and standard deviation. For example, calculate the mean of each row. Every time we say to do each row, then we say axis 1. I think it made a mistake earlier when it was saying axis 0. Axis 0 should be the column, because here it says each row. This makes more sense to me. In this case, it's 2 and 5, because 15 divided by 3 is 5. 6 divided by 3 is 2. These also happen to be the medians. Don't get confused. Median is, I believe, the middle value. Because let's just confirm this real quick. All we need is this. Let's get that. Okay, the average and the median both are going to be 3. But if you were to have here 6 and 7, then the median should be 4. Both the average and the median. But even if this was 10. Now the mean is going to change, but the median is going to stay the same because it's the middle number. Okay. Good. So if you want to calculate each row, so we understand that 2 and 5. But then if you want to calculate each column, it's 2.5, 3.5, and 4.5. Why? Because for the first column, it's 1 plus 4, 5 divided by 2. It's 2.5. For the second one, is 2 plus 5, 7 divided by 2, 3.5. For the final one, 3 plus 6, 9 divided. So, okay. So now we've really realized that, let's actually copy and make sure that this is correct. So we figured out the axis thing for good. Oh. Here we go. Run it. Yeah, that is correct. So axis 1 refers to the row, axis 0 to the column. I hope I am correct. Please correct me in the comments if I am wrong. So we got more of that, more examples for the mathematical operations. Now let's move on to accessing and modifying elements in a Numpy array. Let's try something. Let's see if it'll remember number 5. Tell me more about number 5 with code examples. I'm not sure if it will be able to. Oh, it does. So The reason why I did this is that ChatGPT's memory, if you go to FAQ, see, remember what happened in the earlier conversation. See, approximately 3,000 words. The model is able to reference up to approximately 3,000 words. This is from its own FAQ. So what happens is, if as you're talking more to ChatGPT, if you go beyond 3,000, then it will start forgetting the previous stuff. But apparently we're not there yet. So that's good. Because access and modify elements was the 5th. That's pretty great. Here it says, to access and modify elements in a NumPy array, you can use indexing and slicing, just like you would with a Python list. For example, consider the following two-dimensional array. Okay? To access a specific element is 3 rows, right? 3 rows, 3 columns. To access a specific element in the array, you can use the brackets operator, specify the indices for each element. So, second row, third column. Element in the second row and third column. Yeah, because in the indices start from 0, right? So 1 would be the second row, 0, 1, right? And then this would be the 0, 1, 2, third column, which in that case would be 6. Why? Because the second row is 1, 2, this one. Third column of it is 6. Okay, if you copy this, let's visualize it, and we can print it. If we print it, you'll be able to see it better. So second row, 1, 2, third column, 1, 2, 3, 6. Okay. To modify an element in an array, you can assign a new value to it using the exact same operator. This is the same operator we use with lists, right? So in this case, we are modifying the 6 with 100. If we copy this, paste it here, we can remove that. If we print it, this time instead of 6, we print 100. You can also use slicing to access a range of elements in the array. For example, access the second and third rows. So we are using a slicing operator, just like with lists. Range of elements. Okay, so in this case, if we do this, we get second from second row, second and third row, yeah. Okay, so because 0 would be the first row, so 1 gives us the second row, and then the up to third, meaning the second, because it's upper bound exclusive. And this would print the last 2 rows here, right here. Access the second and third columns. To do that, then we say all the rows. This should indicate that we're considering all the rows, comma, we want the second index because it's 0 and then 1, right? Up to the last second, the third element, which is 0, 1, 2, upper bound exclusive, which would be 2, 3, and 5, 10. Second and third columns. Okay, where is the last one? Shouldn't 8, 9 be there? Let's test this one out. We already have our array. Oh, yeah. Yeah, it has to give the, yeah, 8, 9. See, what happened here is, that in a particular response, is it types, it actually ran out of tokens here, I believe. That's what happened. Let's say, when this happens, I like to say continue from, copy a last few lines, paste it, and then I let it go. Let me check 8, 9. Yeah, I kind of made a mistake here. I believe. Okay, well, let's continue. It says the middle element of each row. It didn't also put this in markup, but that's fine. All the rows and the middle column, which would be 1, if we print it, is 2, 5, and 8. 2, 5, and 8. You can also use indexing and slicing to modify a range of elements in the array. For example, modify the middle element. Again, we select the array, we say all the rows, and the second element, since this only have three columns, this would be the middle element. That's why it's a middle element. Essentially, we're doing the second element column-wise. And then it assigns it new values. So we are effectively changing all the middle column values to whatever this array is providing. Let's test this out. And we run it. Yeah, we get 10, 20, and 30. Modify the second and third rows. Then we, of course, the first index, the first element, if there's no comma, then this refers to the row. After the comma, it refers to the column. Modify the second and third row, because 0, 1 up to 2, and then we assign zeros to it, and it gives us zeros. Run it, and exactly. Indexing and slicing is a powerful way to access and modify elements in Numpy array, and can be used in combination with other Numpy functions to perform complex operations on arrays. If you have any questions, you can continue asking ChatGPT. This video is, of course, to learn about Numpy, but more importantly, to learn about how to use these incredible AI tools, namely, in this case, ChatGPT, to actually allow a learning environment on your own terms. Reshaping and transposing Numpy arrays. Tell me more about 6 with code examples. Let's see if it's going to remember. Reshaping and transposing Numpy arrays. Manipulating and transforming arrays. Okay. These functions can be used to reshape, sort, slice, merge arrays, and apply mathematical operations to arrays. For example, you can use an np.reshape function to change the shape of an array. So here is our array. Reshape the array into a 3 by 3 matrix. Matrix is np.reshape. And do you remember in the beginning it said you have to assign it to a new array. You cannot change the shape of the array itself. That's what it said, at least in the beginning. We can maybe try it. Then we're assigning to the matrix because this is an array, single dimensional, and we're turning it into a 2-dimensional matrix. np.reshape, we give it the array arr is one of the arguments, comma, and then we give it its shape. Then it takes it 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just grab this real quick. Let's talk about this. Let's just run it. Oh, I brought in some extra stuff. Yeah, 1, 2, 3, 4, 5. But see, it has to be, your shape has to match the original array, because if you try to do 2, 3, it's going to say value error, cannot reshape array size of 9 into 2 by 3. Okay, simple as that. But we could do 9 by 1. What happens if we do that? Yeah. Pretty cool. And 1 by 9 would make it like our current array, but still mind this is still a matrix because see, it's between 2 brackets. Okay. We can reshape the array into a 1-dimensional array with 9 elements. Oh, and now we say 9. Oh, and then because Oh, okay, okay. And you know what? We were going to try something. Can we do this? Reassign it to itself. And then print this to 3, 3. Right? Yeah. Okay, cool. Oh, sorry. Okay, and then you can reshape it back. So we've got an array. We reshaped it into a matrix, and now we're going to reshape it back to a single dimension. Yeah. See. You can also use np.sort function to sort an array. So here's an array jumbled up. np.sort array will sort it out. I know this to be true, but let's just see it with our own eyes. Yep. Also, sort the array in ascending order. Yeah. Sort array. Okay, we've done that. Sort array in descending order. All right. We use the same lingo, except we use the same thing as we would use with a list, and then it's in descending order. Let's just see something real quick. I'm just going to use GitHub Copilot's help here. Let's see if it'll suggest any other way of doing this. I mean, because okay, and that's sort. Wait, so we got to give it the array, because in lists you can give the array and then you can say reversed equals true. Is this gonna work? Print sorted array. Yeah, unexpected keyword. So it doesn't have. So Numpy does not have this reverse true. It says unexpected keyword argument. Okay, but you can do it with lists. You can also use np.concatenate function to merge 2 or more arrays together. Here is 2 arrays, A and B. Merge the arrays along the first axis, 0, which is the column, the row wise, and it will generate a new array out of that. And along the, if you do it along the second axis, let's copy this. Let's see it. Here we are. If we run it, axis 1 is out of bounds. Okay, let's see the first one. Sorry, here we go. Yeah, the first one where x is 0 works. What's the deal with this? Axis 1 is out of bounds. Because they both are single dimensions, there is no. Okay, let's copy this. Okay. Concatenating on axis, because 1 gives error. Let's see what it says. Yes, that's correct. It says when we concatenate arrays along an axis, the dimensions of the arrays must be compatible. In this case, the first array, A, is a one-dimensional array with 3 elements. Second array, B, is also one-dimensional array with 3 elements. When you try to concatenate these arrays along axis 1, it gives an error because axis 1 is out of bounds for a one-dimensional array. To concatenate these arrays along axis 1, you would need to reshape them into a 2-dimensional array with a single column. Merge their and then merge the arrays. -1 to 1. That's interesting. Let's copy this. Bring it here. Let's print them real quick. Print both A and B. Yeah, we don't need a separator. So this is what it prints. 1, 2, 3. It's a weird shape. Tell you that. Oh, it's it's doing this. Let's remove this print. Sorry. So this is the 1, 2, 3, 4, 5, 6. It's a weird way of merging. Okay, let's get rid of that and let's see them merged. 1, 4, 2, 5, 3, 6. Okay. Interesting. My linear algebra is not the greatest, so I'm pretty sure some of you do understand this stuff better than I do. Alternatively, you could concatenate the arrays along the first axis to create a three-dimensional array with a single column. Okay, I think we already talked about that. So let's go back. We did the reshaping and transposing Numpy arrays. Say, tell me more. Let's say, tell me more about the same topic with code examples. Let's see, we'll just skip it if it repeats itself. Reshape. So we did talk about the reshape, but we didn't really talk about transpose. Maybe it'll get there. Okay, it did talk about the reshape. We've already covered it. Then it's now talking about np.transpose. Transpose an array by flipping its axes. For example, we have this two-dimensional array, 1, 2, 3, and 4, 5, 6. Transposed equals np.transpose array results in kind of like, so it had 3 columns, 2 rows and 3 columns. Now it's turning into 3 rows and 2 columns. 1, 4, 2, 5, and 3, 6. It's a transpose. Transpose array using the t attribute. Transpose equals array.t. Yep, does the same thing. Okay, transpose is used a lot in matrix algebra, linear algebra, that is. And p.swap axes swaps 2 axes of an array. So we have a 3-dimensional array. All right. Swap the first and second axes. 1, 2, 3. First and second axes. So when it's 3-dimensional, it's difficult to wrap your head around it, but sure, it makes sense to some of you. These functions and methods can be useful for reshaping and transposing arrays to suit your needs. For example, you may need to reshape an array to fit a certain model or algorithm, or you may need to transpose an array to make it more convenient to work with. We will cover more examples later. Reshaping and stacking and splitting. Let's take a look at this. Tell me more about stacking and splitting with code examples. Oops. Example, okay. Numpy provides several functions and methods for stacking and splitting arrays. Here are some examples. np.stack stacks arrays along a new axis. Let's take a look. A and B, 1, 2, 3, 4, 5, 6. Stacked arrays is 0, which would be the rows, and it stacks them in 2 rows. Okay. If you say 1, then oh, it does the 1, 4, 2, 5, 3, 6. So, okay, it's kind of doing like the transpose thing. Stacking does that, I guess. Let's make sure. Maybe run it. Yeah, okay. Cool. hp.hstack stacks arrays horizontally, for example, along the second axis. Create 2 arrays. I don't quite understand what this is doing. Honestly, -1 to 1. Stack the arrays horizontally. Huh. Well, let's copy this and let's ask once we're done. npv stacks arrays vertically. Vertically 1, 2, 3, 4, 5, 6. This looks to me the same thing as just a regular stack. I guess we had to specify an axis here. Vertical stacking obviously doesn't need an axis, perhaps. NP.split splits an array into multiple subarrays along a specified axis. So we have a one-dimensional array. Split the array into 3 sub-arrays. Split it is a split. We give the array as an argument, and 3, 6. Is this the shape or something? Then we get 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 different arrays. Let me just paste it. We're going to ask that. 3, 6. Split the array into 3 subarrays along the second axis. Reshape. So 3, 3, okay. 1, 2. All right. This is a bit beyond me. But, like I said, you can ask more and learn more from ChatGPT. What does this mean? Question mark. Explain it. It simply as I don't understand. Let's find out what this negative 1 to 1 means. It says the negative 1 parameter in the np.reshape function specifies that the size of that dimension should be inferred from the size of the array and the remaining dimensions. For example, consider the following array. Okay. If you want to reshape this array into a 2-dimensional array with 3 rows and 1 column. 3 rows and 1 column. How could that be? You could use all right. Would that really work? The negative 1 parameter can be used in place of one of the dimensions to specify that this. The negative 1 parameter can be used in place of one of the dimensions to specify that the size of that dimension should be inferred from the size of the array and the remaining dimensions. For example, you can use the following code to achieve the same result. This can be useful when you don't know the size of one of the dimensions. Oh, okay. But you want to specify the size of the other dimension. In this case, Numpy will infer the size of the first dimension, 3 rows, based on the size of the array, 6 elements, and the size of the second dimension, 1 column. Let's copy this real quick. All right. And when we run this, yeah, I don't think you can do that. You can do 3 by 2. Yeah. Okay. Negative 1, but the negative 1 is supposed to make it work, right? Because it's going to infer. Let's get rid of that. Oh, no, we need the array. Let's get rid of this. Yeah, okay. Yeah, all right. So we wanted 1 column, and then we say negative 1, and it makes 6 rows. So, all right, so now I get it. I hope you do too. So ChatGPT to the rescue. So we're learning more and more. This stacking, splitting, indexing, and slicing Numpy arrays. We kind of found out about it a little bit, but tell me more about indexing and slicing with code examples. Oh, I made a mistake. Let's see if it'll understand it. Pretty sure. It's jumbled, but to access and modify elements in Numpy, you can use indexing and slicing. Cool. For example, consider the following 2-dimensional array. All right. To access a specific element in an array, you can, yeah, we covered that. Let's see what else it learned. Okay, honestly, it's writing more, but we've covered these. Modify elements, slicing, we talked about, index and slicing. Yeah, okay, so we can skip that. Numpy array statistics and aggregations. NumPy provides several functions for calculating statistics and aggregations on arrays. Here are some examples. np.sum calculates the sum of all elements in an array. Cool. Similar to list. np.mean calculates the average. Yep. Okay, we knew that. Calculates the median of an array, which is the central point. It's going to be 3. np. Yep. Standard deviation. Okay. Are there any other important ones? Let's make sure. NumPy arrays, more like np.min calculates the minimum value of an array. Okay, good to know. np.max, maximum value of an array. Okay. argmin calculates the index of the minimum value of an array. Should be 0. This is interesting. Let's run it. Yep, 0. argmax calculates the index of the maximum. Yeah, these are pretty cool. Okay, 4. Yeah, because 0, 1, 2, 3, 4. I mean, the 5 is at the 4th index. That's argmax, these functions. Okay. Statistic, working with NumPy arrays and Python's built-in data structures. Let's find out about that. Tell me more about examples. You can easily convert between NumPy arrays and Python's built-in data structures, such as lists, dictionaries, using the toList, fromList functions. All right. Consider the following NumPy array, 2-dimensional. 1, 2, 3, 4, 5, 6, and 7, 8, 9. To convert this array into a Python list, you can use the toList function. Let's try that. Well, this is actually neat. Yeah. Okay. To convert the list back to a NumPy array, you can use the fromList. Let's totally do that. It's going to be the same thing. Nevertheless, oh, module NumPy has no attribute fromList. Sometimes. See, that's why. I mean, you can definitely use chatgpt. Just be careful. Obviously, I'm gonna give that in real quick. See what it says. You can also use array function to convert a Python list to NumPy array. So this is what it was. np.array. Let's try this. So instead, this should work. Yeah. np.fromList. There's no such thing as fromList. Convert between NumPy array and Python dictionaries. Is that so? Let's come back to it. Well, actually, let's try. Okay, here's a dictionary. It's gonna try to do fromList again. Let's see. No, there's no fromList. Okay, let's see GitHub Copilot. I have GitHub Copilot. Let's see what Copilot says. See, yeah, array. This works. Yeah, so that's just funny. Let's just read the rest of it. These functions and methods can be useful for converting between NumPy arrays and Python's built-in data structures when you need to work with both types in your code. We will cover more. Okay. Let me just say, I'm just curious. I apologize for making a mistake. That's nice. Yeah, instead use array. Okay. Fine, but we forgive you, ChatGPT. By the way, because of this, NumPy documentation. I mean, here's the NumPy documentation. I mean, this is the official documentation. But I mean, it's just let's see, like it's just difficult to read these. If you have the time, definitely this is the best source, right? But You can just ask anything to ChatGPT. Just remember that it can make mistakes. It can be convincingly wrong. So just keep that in mind. All right, let's just do the last one. Why not? More about this with code examples. I mean, it gave us a lot of examples. I think it was mistaken twice, I believe. That's like, I mean, look at all the stuff. Like, that's still pretty impressive. All right. Thanks for watching, by the way. Please like and subscribe if you're liking it, by the way. Numpy provides many advanced concepts and functions for working with arrays, including broadcasting, masking, and linear algebra. Broadcasting allows you to perform arithmetic operations between arrays of different shapes. Here we go. This is two-dimensional and one-dimensional. Broadcast the second array over the first. So we say C equals A plus B. Oh, it just adds one. So, yeah, adds it to both arrays. Is this? It's just a. Yeah, it works. Okay. Masking allows you to select and modify elements in an array based on a condition. Okay, one-dimensional array. Create a mask. Mask equals array larger than 3. Oh, so it's going to return false for every value that is 3 and under, and true for values that are larger than 3, for 4 and 5. Select and modify the elements using the mask. So we've created a mask for all values that are over 3. And then now we have that mask. We can say AR in brackets, square brackets, mask equals 10. And whatever is true is going to turn into 10. Oh, this is awesome. Wow. That's really cool, actually. I like that. Linear algebra provides functions for performing linear algebra operations on arrays, such as matrix multiplication and singular value decomposition. I think it ran out of tokens. Let's just say continue from. Yeah. Okay, so it's going to do matmul, matrix multiplication, print it. That is not sure how this actually works. We'll definitely test it. Let's just test this real quick. Okay. Perform singular value decomposition. Yeah, totally beyond me. But okay, as a final question, what is singular value decomposition? I don't get it at all. Well, let's see. I don't know it at all. Please be simple and clear in your explanation. Singular value decomposition. SVD is a matrix decomposition technique that decomposes a matrix into 3 matrices: a unitary matrix, a diagonal matrix, and conjugate transpose of the unitary matrix. Okay, never mind. The unitary matrix represents the orthogonal transformation of the original matrix. All right, you know what? I give up. But thank you for watching. I hope you'll enjoy it. This is actually the longest video I have made so far. I hope you'll enjoy it. I enjoyed making it. I actually learned a lot. Let's just think, when it's done, let's just think ChatGPT. Thank you. Thank you very much. You were very helpful. I have learned a bunch. You're welcome. I'm glad that I could help you learn about Numpy. Please don't hesitate to ask if you have any more questions or need further clarification or any other concept we discuss. I'm here to help. Well, thank you. And take care, everybody. Thank you for watching.